You know, I didn't tell you to put that heading. You know why? Because now you will see how you have to cut the column and put it in another place. So if you have a title, then you can't cut and paste. You should know what is written there. The first one is temperature. So you write down, leave the first row empty, and then write the temperature. Group, that one, this one, and this one. Write it.
This in the table.
But remember that temperature here I'm writing is not exactly what you see, eh? You write what you saw on the thermometer. Done? Next column is change this to Kelvin.
Oh, plus 273.
From degree Celsius, change it to Kelvin. Then time, that's what we have to convert and write in seconds.
$273.
Time in seconds. So whatever time you got in minutes and seconds, write the time in seconds for the different temperatures. Now, what you might see is that there are two data here. Right? For one temperature you need two trials, right? So room, you leave a space, then 40, leave a space, 60, leave a space, 80. So that here you can write both the time, eh?
But for us, we don't have to because we just take one because ours is
Then
same. Because our time is same. That's why it will be same. So you don't use writing it twice.
average. And in average you don't use the computer, eh? You write equal. Here you will write equal. Formula. This row plus this row divided by 2 enter. Why I am telling you this? Because if you have to change the mark the time somewhere, automatically your whole result will change. You don't have to come back and do the calculation to every bit. You know how to use formulas in Excel? Yes? But people don't teach you how to create an account on Instagram, eh? You know how to do it, eh? You know how to put the heart on the Instagram without getting any tuition, eh? Because you want to do it. Done? So you get the average. In your manual, we've given you an equation, and that is called a correction factor, which means that if you are using the glass viscometer at different temperatures, the glass might expand a little bit, eh? So there can be an issue in your timing. So if you look at the manual at the back, I have given you a formula. Cp is equal to C naught something. In that formula, the value of C naught should be this, and the value of B should be this. And these two values are at 22 degrees Celsius. If you look at the formula, the T naught should be your 22, the T is yours. And you are asked to calculate a CT. And that CT will come here. With me or not? Problem is you didn't read the manual before coming to the class. Am I right? That's why I told you, the experiment is very easy. Can you see what is measuring the time?
This formula.
If you look at the back of your experimental handout in the manual, you see there is the equation given there. Right?
Yeah.
And that equation has variable of T naught, B, T, right? And there is another T there, which is the place where it is written 23, you should change it to 22. So, the place where you get 23, you write 22. Your T is what? The temperature at which you did your experiment, which is coming from here. But we are not using Kelvin because it is already in 22 degrees Celsius, right? So you have to use the temperature in degrees Celsius. Plug it into that equation and calculate the CT at room temperature, the 40 degrees one, 60 degrees one, and 90 degrees. You find that it will be almost same. Why? Because the viscometer is made from Pyrex glass. And one of the properties of Pyrex glass, they do not expand easily due to heat. And 90 degrees is very low temperature. Eh? So you expect your CT at different temperatures to be same. Done? Understood? Understood? Understood?
Yeah.
Which will you? Can't be everything. Can't be. Temperature, you don't understand the temperature. The one that you do the experiment on? Which one? TT. Check the formula in your manual. Check the formula in the manual. And then manual has which variable there. T naught there. That will go there. Apply B. Put B the value there. The constant is the B. And then you find your CT.
50, 10 to the power of negative 2.
Yeah, I can't see properly.
And the temperature from 22
Record.
to 22. So the correction factor for the viscometer, you do it for each temperature. And as I said, the temperature is not changing like in drastic value. So your CT should be almost same. Whatever the CT is at 25, room temperature should be same as around 80 degrees. Right? Done? Understood? The next point is to go and calculate the kinematic viscosity. So, next column. What's the formula for kinematic viscosity?
Sure.
It's given in your manual.
What's the formula? It's in the front.
Kinematic viscosity?
T by convection. Convection.
V is equal to the U over density, or V is equal to
A times T plus V over
you look at equation 1 main. Kinematic viscosity is my pen is giving up too. Kinematic viscosity is what?
T by
Time
convection.
multiplied by.
Conversion factor.
So you will write equal to this multiplied by this. In your Excel file, it will be equal to this correction factor multiplied by the average time. So you will get your kinematic viscosity. Done? Then in the next column, I need to get the dynamic viscosity, which is this. According to this formula, equation 2, I need to get the mu, which is dynamic viscosity. I need to get that, and from my table, I now know the kinematic viscosity, which is this multiplied by this. What is missing? What is this? Please, what is that?
Distance.
Density of water at this temperature that you have recorded. For that we didn't do the experiment. Why? Because the density of water is rarely available. So you go to a credible reference. Just don't go to the internet and pick up anything. Because if I come back and ask you where did you get the value from, and that person has removed his site, you are lost. You need it from a credible reference. That means the reference will remain there even though if you die. So get the credible reference and find the density of water for the temperature that you have done your experiment on. Write it here, and it could be in grams per centimeter cubed. But be careful, when you do the calculation, you will need to see whether you need to put it in gram per centimeter cubed or kg per meter cubed. You get the values from the internet or from a credible reference, then you calculate the dynamic viscosity, and that would be kinematic viscosity multiplied by density. Remember, the kinematic viscosity is given in millimeter squared per second squared, and the density is in grams per centimeter cubed. Can't match it. It can't match because one is millimeter squared, one is centimeter cubed. So you will need to convert your kinematic viscosity to meter squared per second squared, and density should be in kg per meter cubed. So meter can cancel off. Get it? Then you come to your dynamic viscosity. And this is what I was telling you right in the beginning. The experiment is simple. The story that comes after the experiment is what is going to eat up your mind. So once you know the dynamic viscosity, the Irene's equation which is given there to calculate the activation energy of viscous flow. And in order to do that, what is Irene's equation? Irene's equation?
Mu.
Mu is equal to A
Tell.
EA over RT. Am I right?
Yeah. Yeah. ERT.
You did this in CH101, not Irene's equation. You did Irene's equation. Remember? Instead of K, you mu, I had K, rate constant. If anything is raised to the power, how do I bring it down? You do that? If something is raised to the power, what the inverse of that?
LN.
Ln. So if I take the natural log, then it will become Ln mu is equal to
Small e at the
Ln
bottom.
plus EA
It's
over
missing.
RT.
The small e.
Then it looks like a straight line. Y is equal to
This e.
mx plus c. And my y is this, and my x is this, 1 over t. If you plot the graph of Ln mu, which is dynamic viscosity versus 1 over temperature, the line that I get should be straight line, and the slope of the straight line is equal to EA over R, and if I multiply the slope by the R value, I will get the EA, activation energy.
So this
Clear?
one, small e at the bottom as well. The equation.
Oh yeah. Anything raised to the power, EA. Exponential. So, once you do your calculation, you find the value of EA. How do you know you are right? You need to compare your calculated value with those EA values that are published in literature. And if your value is close, like plus or minus 1 kilojoule different, then your data is correct looking at the situation we did the experiment. But if the data published is like 15 or 16 and yours is 200, then something is wrong. Go back and check where you made the mistake. I know it's hard. What people will do, leave it till the last minute. Okay? And if you leave it till the last minute, we'll mark like the last minute. And you might lose a lot of marks. It is hard, I'm telling you. That is why it is called physical chemistry. It is hard. Can you see it full of maths and calculation? Physics, maths, graphs. So from here we should be able to explain what is happening to water molecules in terms of intermolecular forces. Any questions? We still have time. That is why I asked you to bring your laptop so that 50% of the work would have been done here. Once the data goes in, now, after that, if you plot the graph, and you realize that during the plotting of the graph, one data is here, one data is there, one data is here, one data is there. 1, 2, 3, 4. It should get a straight line, eh? This one is odd. Right? Can we adjust that data? Yeah? If 3 are right, 1 is out, can we adjust that? So that it can come here. Yes or no? Because if you had repeated the experiment, it might come there. You get what I'm saying? I'm not telling you to go and make all the result. What I'm saying, according to that line, you see only 1 is out. You get it? If all of them were out, then you can't do anything. If 3 of them are on the straight line, then obviously this is playing up. Because of this, your other data might be wrong. Can we put this up? Yes. Are you going to go back home and do the calculation? No. What you're going to do is come back. What can you play around with? Can you play around with the density? No. What can you play around with? Time. So as soon as you make a change in the time here, it will automatically calculate everything and your graph will change. Just one change here and you will see. If you see it goes totally out, come back. You will undo. But if you don't use this, then you'll have to sit down and do all the calculation on your own on the calculator. Consumes a lot of time. So if you go by this, you realize that this is 1, 2, 3, okay, 60 degrees was the one that's playing up. Then you might see you got one data here, one data here. If I take the average, because one data is wrong, and if I'm taking the average, it's giving me a problem. Forget about the average. Remove this data and then write this one here. And check what happens. If we change it, let's forget about the second one. Eh? Just keep one data. Get my point? But if you do it manually, oh boy, and it will leave it like that. It will consume a lot of time. So understood what to do now? Remember, you will have to understand it, because if I ask you the same question in the lab test and you can't give me a systematic explanation, that means you don't know. And you are not coming here just for the sake of passing the course. We are training you so that one day, if I am needed for you to be in your home campus and do this lab for me and explain it to the student, then you should be able to do it. And if you tell me, no, I don't know, I just passed, then what the use? Then what the use of study? There is a purpose behind why we are giving you all these things, so that when you go out, you should be able to understand and explain and do similar kind of experiment that requires equations like this. Right? That requires equations like this. That if you have a power, how do you bring it down using Ln? And if you plot a graph, what can you expect? Understood or lost? If you are lost somewhere, tell me which place. Which one? Huh? This one. You okay with kinematic viscosity? That is time multiplied by the Ct. In order to get this, what's the equation there? Kinematic viscosity is equal to dynamic over density, right?
Yeah. Density.
Mu is equal, kinematic is equal to dynamic over density, right?
Yeah.
Now how can I get this?
Just not.
I have to take the density that side, here.
Density by.
Do I have this already? Yes. This one I have to get it from literature. So if I get the density here, so this multiplied by this will give me. Now the other thing I was telling you, be careful with the units. Kinematic viscosity, what's the unit? Check. In the formula I must have given it in the left menu. Change it around. No. I think the formula here would be, if you go by the CT and read this, is millimeter square per second square. Please check. Right, I think it's millimeter square per second square. You get it? If you go and check on the internet, it will show you that correction factor multiplied by time is millimeter squared per second squared. But if you come and look at density, it's going to be grams per centimeter cube.
Cube.
Can I multiply these two? Millimeter, centimeter. So the best thing to do is take it to
Centimeter.
meter squared per second squared, and this one kg per
Meter cube.
cubed. Convert the density from gram per centimeter cube to kg per meter
Meter
cube.
cube.
And the kinematic viscosity millimeter squared per centimeter, millimeter squared per second squared to meter squared per second squared. Then you can get your dynamic viscosity. And once you get your dynamic viscosity, then you put in another one which is Ln this, according to this, and your temperature which is here, you might create another column here and make it 1 over T. So the temperature in Kelvin, 1 over temperature. So if you have to plot the graph, it would be this y versus, this is your y, this is your x. So as you see, the theory part is easy, isn't it? The theory part is easy. That's why I'm not asking you to write the introduction. In your report, it should be the
X is
methodology
1 over temperature.
and the detailed version of your experiment, calculation, results and discussion.
Yeah.
Any question? All understood?
Kelvins.
See, the place where you might make mistake is conversion factors, right? When you are changing from meter cube to centimeter cube, then that part you might make a mistake. Or when you are converting, when you are trying to find the correction factor, you might make a mistake, with the calculation. The biggest part is that when students do the calculation on the calculator and it's written like this, 6.0 times 10 to the minus 6, and they don't see the minus. And then they write the 6. Right? They overlook the minus and then write the 6 only, so your data will only see the out. Minus 6 and 6 is two different values. So go back, when you see that your answer is not coming to the expected one, go back. And because you have the Excel with you, you just have to play around, that's all. But if you have all your data scattered, you don't want to go back and look at it. Okay? Still anyone in doubt? See, my expectation is, the reason why I go like this and I keep on asking you, imagine next day I ask you, or year after next I ask you to demo. Right? You come in and be a demonstrator for 203. Right? And then I ask you, can you please explain? Can you do it? You should. That's my expectation, you should. If you think you are not good at that, go back and read. Two years later, you might forget a little bit, but if you slept your mind a little bit at home and then you say, oh, yeah, this is what we did. Now, the reason why we have to do all, I'm just using water here because we could have used some interesting solvents like oil. Why should you not eat coconut oil? So we could have looked at the activation energy, isn't it? How much energy it takes for it to slide down your gut. But the big problem would have been cleaning part. To clean the viscometer with the oil all stuck inside is too difficult. Then I have to get potassium dichromate with ch203, soak it there for almost 24 hours. Too much work. So I use water.
Easy.
So the question is this, when you look at the activation energy, what can you say about it? Right? And remember, this is activation energy of viscous flow. How much energy is required for it to overcome the flow part? You know, we always talk about, oh, we want to go green energy. Oh, use biofuel, plenty coconut in our country. Yes? Do we use coconut oil in the engine? What do we use? Can't use coconut oil, your car will finish, jam up. It will go for some time and then you will see the black smoke coming out, then white smoke, after that stop. Why can't we use it? Because the viscosity of the coconut oil is very high compared to diesel. So what do we do? How do we bring the viscosity down?
Decrease the intermolecular process.
We actually make it into an ester, which you did in organic chemistry last year, last semester and last year. A carboxylic acid plus an alcohol. Where do we get the carboxylic acid from? Coconut oil. Where do you get the alcohol from? You ferment starch. Then you get ethanol. If you oxidize it more, then what do you get? If you oxidize ethanol, what do you get? Ethanol. Alcohol goes to an aldehyde. If you oxidize it more, you get a carboxylic acid, which is vinegar. When they say apple cider vinegar, that means the vinegar is coming from fermented apple. Did you learn all this?
Yes.
Anyway, here we will have to get the alcohol, then you add it with coconut oil, and then add a little bit of base, what we call base hydrolysis. If you add acid, then it's going to be acid hydrolysis. Then you hydrolyze, then you get an ester, and you get glycerol. So when you get glycerol, what do you do with it? You sell it to the food industry. And with the ester, you use it as a biofuel. Then if you put it into the diesel engine, the engine gets confused whether it's diesel coming or something else is coming, because it basically works on the viscosity. So the viscosity of biodiesel should be same as diesel. So which one would have a less viscosity? Ethanol or methanol? If I use ethanol in coconut oil and methanol in coconut oil, which ester will have a lower viscosity? Methanol. The longer the chain, the higher the viscosity. Did you see the application bit of it? And you don't see any chemist going into the biofuel area because they don't understand. Simple as that. So the question now is, if you have to do that, then you have to understand. Because when the fuel goes into the engine, does it burn at room temperature? No. We have to see how the fuel behaves with increasing temperature. That's what I showed you. So if you increase the temperature, what happens to the viscosity of the liquid? Decreases. So there are some of the application areas where this experiment is very handy to explain to people what will happen. Something that they can't see, you should be able to see. Get it?
Yeah.
Now you see it's interesting, the information you get out of it, then where can that information be used in the development? Now you tell me, if you look at Pacific Island countries, we have the natural resources. We send students to come and study. You see, a lot of bulk here, Tongans. And you arrive into Tongatapu airport. What's that airport? Kuamoto. As soon as you start landing, you can see only coconut trees, and what do we do with it? So when people who were before you, they knew the value of coconut, that's why they planted it. But the technology was not there to utilize it. Yes or no? If you come next year to do ch203, then I'll show you how you can get nata out of coconut, which is what you called coconut jelly. When you go to cha time, here in Suva, when you go down there and buy a juice and they'll put some pepper balls in it and then some white jellies in it. The white jelly is nata. It is a fermented part of coconut water. And then the purplish ball is what? Starch, cassava starch. We don't make it here, we buy it. We buy it. All those things come from overseas. You just put it in the juice and give it to you. Can we make those cassava balls here as well? Yeah. What do we do with it? You don't know. And that is the reason why we keep on telling you, you need to understand the physical aspect of what happens in chemical reaction in organic compounds. Have you come across the word gelatinization? Gelatinization. No. Have you made roti at home?
Yes.
When you put hot water in the flour, what happens? That is gelatinization. You can't bring it back after the starch gets gelatinized. You might have noticed as well. If you try to make the dough using cold water, then your texture of your bread or roti is very hard. If you use boiling water, then it becomes soft. Why? Because we break up the starch molecules. And that is, when you break up the starch molecules with heat, we call it gelatinization. And that is how the starch balls are made. You go to the supermarket, they call sago seeds. Sago seeds, again made from cassava starch. Again, in Fiji, what do you do? Eat. And then we blame the food. Obesity. NCD. Yes or no?
Yeah.
We plant, we eat, we blame the food. So as a chemist, we need to start looking at ways in which we can change that mindset. It is because with us we can see the experiment that we did was so simple. Can you see how many things I got out from that experiment and telling you what which you couldn't see? But now you should be able to see why it's happening that way. You asked me that how do you know the intermolecular forces is becoming weak from EA? Yes or no? If the EA goes down, what does that mean? That you require less energy to flow. If the EA is high, it means you require more energy to flow. Okay? So that's all I have for you today. Then pick up, go home and start using, put your data into Excel and try and get the graph done. If you can't get your graph done, come and see me. So if you give me something like this, then I can help you. Then once your graph looks okay, then you go and write it. Okay? Because then you know that you just have to write. Right, we'll see you next week. Tuesday, same place, same time.